Let's continue with determining the next point on our unit circle, which is going to be a 45-degree angle, or pi over 4. From the previous slide, I generated a 45-45 right triangle inside my unit circle. Again, I've done that here, and I know that in a unit circle that my hypotenuse or radius of the circle is equal to 1. I also know that I can convert 45 degrees by multiplying by pi over 180 into a radian, which in this case will be pi over 4. Again, recall from my previous video on special right triangles that in a 45-45-90 triangle, I can determine the legs by taking the hypotenuse and dividing by the square root of 2. So 1 divided by the square root of 2, and then I rationalize by multiplying by the square root of 2 over 2, will give me the square root of 2 over 2. And that will give me my x value, if I refer back to my unit circle, and also since this is an isosceles right triangle, that will also give me my y value. Now from here, I can find my circular functions as I did on the previous triangle by starting with the sine of s, and in this case it's going to be pi over 4, and the sine of pi over 4, which is going to be my y value, which is the square root of 2 over 2. The cosine of s, or pi over 4, is going to equal my x value, which again is the square root of 2 over 2. The tangent of s, or pi over 4, is going to be y over x, which equals be the square root of 2 over 2 divided by the square root of 2 over 2. When I simplify, the square root of 2 over 2 times 2 over the square root of 2, I'm going to get tangent of pi over 4 equal to 1. From here, I can create reciprocal functions of cosecant, secant, and cotangent. I can also refer back to my unit circle and create other angles that are going to have very similar terminating points on the circle. For example, if I create an angle that is 135 degrees, or 3 pi over 4, that will generate a reference angle, which again is 45 degrees. The point is very similar to the point at 45 degrees, except the signs change because x and y values change positive and negative in quadrant 2. Again, if I create a 225 degree angle, which is going to be 5 pi over 4, that's going to generate a 45 degree angle. Again, the values for x and y are the same, but the signs are different because in quadrant 3, x is negative and y is negative. And finally, if I generate a 315 degree angle, that will give me again a reference angle of 45 degrees. And the terminating point is still going to be the square root of 2 over 2 and the square root of 2 over 2, but my x is positive and my y is negative. Let's continue by taking a look at the next point on a unit circle. Here, I have an initial side of the angle, and I have a terminal side of my angle. This is at 60 degrees, or pi over 3. Notice that the terminal point is at 1/2 square root of 3 over 2. Let's see how this is generated. Here, I have the similar triangle from the previous slide, a 60 degree angle. That'll give us a 30, 60, 90 triangle. And I know that I'm at 60 degrees, which is multiplying by pi over 180 is going to give me pi over 3 radians. Here, again, I know that my unit circle has a radius or hypotenuse of 1, and therefore I can generate the short leg by taking the hypotenuse and dividing by 2. This will give me my x value. And when I take my short leg, I can multiply that by the square root of 3 to determine my long leg, which will give me the square root of 3 over 2, or my y value. Again, I can create my circular functions. Sine of pi over 3 is equal to y, which in this case is going to be the square root of 3 over 2. Cosine of pi over 3 is going to be my x value, which is 1/2, and tangent of pi over 3 is going to be y over x, which equals the square root of 3 over 2 divided by the x, which is 1/2, Continuing to simplify, I'm going to get the square root of 3 over 2 times 2 over 1, which will give me the tan of pi over 3 equal to the square root of 3. I can continue and determine my reciprocal functions of cosecant, secant, and cotangent as we have in previous slides. I can go back to my unit circle and see that I have generated the point of x equal to 1/2 and y of square root of 3 over 2. I can continue by creating more angles inside my unit circle. Here, a 120-degree angle, and create a reference angle, which will give me 60 degrees. Again, I will generate the same point of 1/2 and square root of 3 over 2, but here x is negative. Again, I can go and create another angle, which here is going to be 240 degrees. That will give me another reference angle of 60 degrees, generating 1/2 and square root of 3 over 2. But again, x and y in quadrant 3 are both negative. And finally, another angle generated inside my unit circle at 300 degrees will generate a 60-degree angle, giving me again 1/2 and the square root of 3 over 2, but in quadrant 4, only my y is negative. Let's determine the circular functions for my quadrant angles. Here I have a 0-degree value. I have a terminal side and an initial side that's going to give me a point on the circle of x equal to 1 and y equal to 0. I have that already set up here, that x is 1, y is 0, and in a unit circle the radius is always going to equal 1. Now all I need to do is find my circular functions. The sine of 0 degrees is going to equal my y value. So the first quadrant value is going to be 0. Cosine of 0 degrees is my x value. Therefore, it is 1. Tangent of 0 is going to be y over x. Y is 0. X is 1. Therefore, tangent of 0 is 0. The reciprocal functions is going to be cosecant of 0 degrees will be 1 over y, which equals 1 over 0, which identified on previous slides is a constraint. Therefore, cosecant of 0 is undefined. Secant of 0 is going to be 1 over x. Therefore, this is going to be 1 over 1, which is 1. And cotangent of 0 is going to be x over y, which will be 1 over 0, which again from previous slides is a constraint, and therefore this is undefined. The rest of the quadrant angles are found in similar fashions, but just recall that r is always going to be 1 in my unit circle. Finally, this slide shows us the domains of circular functions. The domains are values of x that give our functions real values. Here, sine and cosine have a domain or x values that can range from negative infinity to positive infinity. On the next two steps, tangent and secant and cotangent and cosecant show us values where there is a constraint on our arc length or radian value. Here is where our functions are going to be undefined. And we found that on previous slides. We just have to make sure that anytime we determine the 6 trig functions, we know where those values are. And those values are always going to be determined where there is a 0 in the denominator of my function.